still am going to email you kind of a written summary, but just to revisit the analyses that we're doing, the 5 scenarios that you're assessing, 1 through 4 are kind of like for the hypothetical person that I assigned to you with that big paper that has all the data. And then scenario 5 is your own profile. And so you can modify your expenses, you can choose whatever retirement age that you like, and you're going to have to find some way to die with zero, whether it's spending, giving away money, or retiring early. The objective is that optimization, that your cumulative assets at the end of the period that you assume is somehow at zero. And maybe that's not what you're going to do, but this is just a case study. So this is kind of like an illustration of one way that you could do things. So I'll email you the written description of the project, but even if you want to get started now, I think between the data and these instructions, you can make really good progress. All right, so let's look at the announcements here. You've got a homework assignment that's going to be related to the in-class exercise we'll do today. Let me give you that paper. The homework assignment is due on Tuesday, which is a pretty quick turnaround. You've got 5 days for that, but there's only 2 problems. So there's one problem related to some of the ideas from the project. That's on the back side of the paper. And on the front side of the paper is a problem related to budget limits, which we're going to talk about today. So that's going to be on Tuesday of next week. Remember, you've got until our last class meeting, Thursday, for the project. Any questions related to the announcements before we start talking about capital rationing?
Could you go back to the project slide real quick?
Sure. Yep. Sure. You're welcome. Okay. So just to look at the schedule, we're getting towards the end of the semester. I think it could be instructive for us to take a glance at what's happening until the end of the semester. So let's do that. If we look at the schedule, that shows the homework which is due. The homework which is due on Thursday of next week. That's homework 8. That's the one that you just got. And then there's going to be an assignment due the following Thursday, so Thursday the 13th, and that's your last homework assignment. So you've got the one that you have in your hands now, which is only 2 problems. Homework 9 will be more than 2 problems. And then the project due on the 20th. So we're kind of in the home stretch now. And by the way, our final exam is going to be on Tuesday the 25th from 4 to 6. And so we'll be here a little bit later than we usually are. We usually quit at 5:15. We'll go all the way to 6 o'clock on the day of the final. Well, I'll be here till 6. You can finish the exam quickly and leave whenever you want. But Jace?
What does it consist of?
The exam is comprehensive. So it'll include material from the entirety of the course. So it could be stuff all the way back through question 1, where you're just calculating interest, using the time value of money factors, time value of money equations, everything. There will be added emphasis on the material that we've covered since the second midterm exam. So a proportionally greater number of the questions, or more of the points, will come from the material that we covered after midterm exam 2. So like the budget limitations that we're doing today, price demand, break even, like these topics, there's going to be proportionally more points on the final related to that because you wouldn't have been examined on it. But there will also be questions from all the way back. So you'll need to bring your computer for the exam, and you can bring 3 equation sheets if you'd like for the final exam. You can bring the one from your first exam, the second one, and you can make up a fresh one as well. So it can be 3 pages. All right. So let's talk about capital rationing. Every organization, even the richest company or the most wealthy government has limits on their available investment capital. And as a result, they sometimes have to prioritize their projects. And that's even true. Do you know where these projects are done? Yeah, that's right, the United Arab Emirates. I used to live over there in Dubai, and I remember going to the beach, for example, and seeing the boats that were doing dredging to build this artificial offshore island called the Palm. And I remember driving by a big hole in the ground that later became the tallest building in the world, the Burj Khalifa. And I remember reading in the newspaper discussion about a new underwater hotel that they're going to build, but they never built it. And it's because of capital rationing. Even a really wealthy government that seems to be able to do some of the most crazy and spectacular projects sometimes has to draw the line and examine, like, what are their priorities? And so how do they know how many projects to undertake and which projects to undertake is what we're going to talk about today. When you don't have unlimited money, but there's many, many different options, how to decide which bundle of priorities you should select. So you do that through a process called a capital budgeting study, and we're going to do that today with Excel. I've got an in-class exercise that we're going to work through together where you look at a series of different alternatives, and we have to find out, first of all, of those alternatives, which are even feasible. Because sometimes we can do an initial screening, and some of the alternatives can be rejected completely, even before we start to assemble them into bundles. And you do that first part of the capital budgeting study by preparing a cash flow estimate and looking at the present value of each alternative. So we've done this process before where you know the initial cost, you know the maintenance and operation cost, you have an idea of the revenues that might be generated, and so you find the present value of the entire project. You'll use some interest rate, you have an assumed duration of the project, and so on. In this process, you'll do that analysis for every alternative, and then you're going to assume that either a project there is a yes or a no, but we're not going to have any partial funding. And we've talked about partial funding before when we were doing the cost effectiveness analysis, when we were trying to figure out, for example, remember the idea of the poachers, when we're trying to analyze which non-governmental organizations should be selected to try and maximize the number of poachers who were arrested. We were picking some combination and trying to decide which office we should prioritize. So it's a similar notion here where we want to prioritize the most profitable projects first, and then you take whatever leftover money there is, and then you invest in the next most profitable project, and then your least priority would be the project that gives you the lowest return on investment. But one of the assumptions that we'll make is that projects are either a yes or a no, just for simplicity's sake. Now, what limits how many projects you can select is the cumulative cost of some bundle combined with the budgetary constraint. And so that'll just be a given. Like, you'll know at the outset of a problem like this how much money you've got available to spend. And what we'll look for, our decision criteria, is maximize the return on investment. And specifically, we'll just look at which bundle of options gives us the highest present value. So we'll pick the bundle that has the highest present value. Okay, now I've used the word bundle a couple of times, and we'll talk about that in a minute, but here's just kind of a pictorial illustration of the process, where we've got three projects, project A, B, and C. And you can tell from the diagram here that project B is really expensive, project C is really cheap, and project A is somewhere in the middle. Now, in this, they don't necessarily have to last the same number of years. So that's a discrepancy that for this kind of analysis is okay for us. So they don't necessarily have to be the same duration, because we're not comparing alternatives for one use. Like when we were looking at different servers or different types of construction equipment, we were trying to pick one alternative when those were mutually exclusive. But in this case, these alternatives are not mutually exclusive. So we can do A, we can do A and B, we can do A, B, C, we could do only B and C, or there's also the do nothing alternative. That's one of the options, is reject all of them. So we can only spend as much money as we've got, or as much money as we're able to borrow, depending on the increasing borrowing costs and so on. And so we'll select either from 0 to 3 of the projects and find out, when we put these cash flow diagrams together, which of them is going to maximize the present worth. Okay, so bundles. This phrase bundles. What I mean by that is there are packages of alternatives. And let's just say that we've got 4 possible projects, A, B, C, and D. So M is the number of projects, and that's 4. So here, M equals 4, because that's how many options we're considering. The number of bundles is 2 to the M. So 2 to the 4th. So that means it's 2 times 2 times 2 times 2. So how much is that? 16. 16. So what that means is there's 16 different permutations of these 4 options. And sometimes this is a little tricky to get them all. Let me pause for a second, and I'd like you to practice this. See if you can identify what are the 16 different bundles. And what I mean is, one bundle would be only A. One bundle would be only B. And so on. There's a bundle that is like A and B. There's a bundle that's A and C. There's a bundle that's A and D. So how many different combinations can you find? Try and write all 16 of them, and then I'll put it up on the whiteboard as well. I'll give you just a minute to try and think through what are all the 16 different combinations. And by the way, A, B, C is not different from C, B, A. That's the same thing. So it's not just like rearranging the order of them. Chase, let's go through it. What have you got?
A, AB,
Okay.
ABC,
Yes.
ABCD,
I like it.
AC, AE, B, BC, BD, C, D, CD, DAC.
Hold on. DAC?
Yeah, I can do that.
So we just call that ACD. ACD. All right.
ABD,
All right. Right.
BCD.
Uh-huh.
Oh, I think I'm missing one. It starts with
Yeah,
B.
I got the same ones. I don't know what I'm missing.
BDA, is it? No.
It's the same.
Anybody know what the last one is? It's a trick question. How could it be a trick question?
Oh, 0.
None.
0, yeah.
Right. None is one of the options. Okay. That was very systematic. I've never seen it where you go through like all of the A options. Like the approach that I did is like A, B, C, D, then A, B, A, C, A, D, B, C, B, D. So, I mean, I like this approach, like use up all of the A's, then move on to the B's. But anyways, okay, so these are the 16 bundles. We've identified 16 options. So from here, what we're going to do is we're going to start up Excel, and we're going to calculate the initial investment required for each bundle based on A is 10,000, B is 5,500, C is 8,500, D is 15,000. Okay, so let's start Excel. Does everybody have their computer today? All right, so just with the blank workbook to begin with, let's skip a couple of rows, and then we're going to have the bundle number, combination, cost, and then possible. Okay, so we've got to basically transpose our 16 bundles. So like do nothing, and then there's A, B, C, D, A, B, C, D, A, B, A, C, A, D, B, C, B, D, C, D, A, B, C, A, B, D, A, C, D, B, C, D, A, B, C, D. All right, 16 bundles. Now, the cost of do nothing is 0. The cost of option A is 10,000. Oh, got to use a negative value here. 10,000 since it's an outflow. B is 5,500. C is 8,500. D is 15,000. Okay. I want to show you a kind of an interesting little shortcut that sometimes works in Excel. I think it'll work here. Okay, so see this option A? What cell is option A in right now? The amount. What cell is that? C7. It's in column C, row 7. You see over here where it says, where is it? There, C7? You can give names to cells. Like you don't have to always refer to it as C7. Like you could name that cell Toyota. Or you could name that cell Pickles. You can name it whatever you want. And you can type that name in here. So let's just name that A. Now, if I use a formula and I just use the letter A, it's going to refer to that cell.
That's cool.
It could save us some time. So instead of C8, I'm just going to call that B. Now, this is where things go sideways. I don't think we can call this just C because it already starts with C. I don't think we're going to be able to call that just C by itself. Yeah, it won't. But we can do this one. We can call this D. All right, so why would that be useful? Because this is going to be equals A plus B. Equals A plus, well, C I don't have, so I'm going to have to do C9 for that, right? Equals A plus D. Equals B plus C9. Equals B plus D. Equals C9 plus D. Equals, so I won't narrate it, but just calculate the cost of each bundle. Okay, so you've got the cost of each bundle. According to this problem, our budget limit is $23,500. So there's 16 bundles, but how many feasible bundles are there? So 23,500 is acceptable. 23,501 is not acceptable. So let's, instead of doing it manually, because that could be tedious if you have lots of bundles, up here at the top, let's define our budget limit. So B equals negative 23,500. So that is the limit for what's acceptable. Now over here for possible, we're going to use the if function in Excel. So if it's been a while since I used the if function, so we'll stumble through it together. So equals if, okay, logical test. So what we want to say is if the amount is less negative or equal to B, then we should have it say yes. And if the amount is more negative than this budget limit, then it should say no. So if this is greater than or equal to B, then we want it to say yes. Otherwise, we want it to say no. Now, the reason why I said greater than is, remember, these are negative numbers. So if it's 23,500, that's okay. If it's 23,501, then that means it's too negative, too costly, so it should say no. So let's see. It says yes because 0 is acceptable. It's above our budget limit, so that's okay. So if I drag that down, oh, did I anchor my reference to B? No, I need to do that. See how it's referring up here to the budget limit? I need to put in the dollar signs so that it always looks at that cell location with the anchoring. Okay, so now the next one, if I drag it down, yes, 10,000 is okay, 5,500 is okay. Where are we going to look for the first no? Where's the first place it should say no? AD. Hopefully, let's see if I've got this in right. It'll say no because AD is too negative. So what was the logic again? If this value is greater than or equal 23,500, then it's a yes. But if it's less than the limit, so negative 25,000 is less than negative 23,500, then it says no. So the statement isn't true, so it goes on and it does whatever is in this third area here, which in our case is text. If we wanted, we could have it return a number, but we're just having it return some text, and it'll tell us which of these are possible and which aren't. So some of the bundles are feasible, some of them are not feasible. Okay, so does everybody feel pretty good about this? The idea that, how many bundles there are, which of them are possible bundles. Like, so why is A, B, C, D not possible? It's too expensive. We don't have that much money. We can't do all 4 projects. So we have to choose. Well, which project should we choose? I don't know. Should we choose the cheapest project? Well, that would be do nothing. But if you do nothing, you get no profit. So the decision criteria, like which of these options to select, well, first of all, eliminate the bundles that aren't feasible. So let's do part 2 now. This was part 1. And in the handout, there's basically 2 sections to this question. It says, find out how many feasible bundles there are. So how many yeses do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 feasible bundles. 10. Okay, part 2, we are going to calculate the present value. So for each project, we know the initial cost and also the annual net cash flow. What that means? It is the revenue minus the cost of doing the project every year. So basically, this is your profits. The annual net cash flow is how much profit do you get each year, in this case for 8 years, and we're using a minimum attractive rate of return of 12%. Okay, so what we're going to do, I'm going to set this up, but then I'm going to pause and circulate around and watch you do this part. Do you have a question?
Can you go back to the what if cell?
Sure. You want to look at the formula?
Yeah.
So the way to do greater than or equal to is you use the greater than and then immediately after it have the equal sign.
Could you repeat it? No, I'm looking at the text. Are those, are they one,
It's 2.
Okay.
Yeah. What does it do if you have 1? Does it give you an error?
Yeah.
I can never remember if it's 1 or 2. It was just dumb luck that I got it right this time. Okay. So by the way, how could we have written that logical statement? We could have said, if it is less than, then have it say no, otherwise say yes. So let me try that. If this is less than that, then it should say no, otherwise it should say yes. Now, with that, I don't even have to do the equal sign. Yes. Let me drag that down through all of them. Oh, wait.
I think you
Oh, less
you
than
put
or
the
equal
cost.
to. Yeah. I still... okay. Let me switch that. Less than or equal to. Okay. So is it getting the 23,500?
Well, I think you put, instead of the 0, you put the cost column there. So everything is down 1.
Oh, you're right. You're right. I tried to outsmart myself. And I didn't anchor the reference. Eventually it will get it. So yes. Okay. No, it's still giving me no here. Maybe I need to put the equal sign before. Well, I'll just do undelete. I had it right the first time. Okay. No. Okay, so 23,500 is okay. This is back to the original logic statement. So Ben, did you get what you needed from this one?
Yeah, I'm good.
Okay. So for part 2 is where we are going to try and decide which bundle should we choose. Like, what's the most profitable? Okay, so put in the MAR, put in the number of years, put in the initial cost, or well, our, I guess we don't necessarily need to have B referenced a second time. So we're going to have bundle, cost, annual net cash flow, and then PW of bundle. The present worth of the bundle is going to be the present worth of the annual net cash flow plus the present worth of the cost. So which of our bundles are feasible are the only ones that we put here. So the feasible ones is do nothing. So that's possible. All of the ones that it said yes for, we want to analyze. A, B, C, D, no. A, B, A, C, B, C, B, D, and C, D. There were how many? There were 10, I think. And we've counted out 10 of our bundles. All right. So you need to find the cost for each one of them, the annual net cash flow for each bundle, for not just the individual ones, for like each group. And then here in the present worth, you're going to add together the cost and the present worth of the annual net cash flow. So remember, you're going to do the PV on the annual net cash flow and then add on top of it the cost, which is an outflow. So the costs are negative, the annual net cash flow is positive. So let me pause for a second, and I'd like you to give this a shot to find out which bundle is the most profitable. Okay, so we put the cost for each bundle in. So here's B, C, and so on. So we've got all the possible bundles, and then the cash flow that is coming in was given here. So this is the annual net cash flow data. Let me just copy this table over so I can see it while I'm typing things in. Oh, that didn't paste like I'd want. All right, so for example, B is 1,300. C is 2,100. D is 3,200.
You don't want to type those, it'll let you drag on the cell from the side over. It'll let you drag from the side to the left of it over.
From the side of what?
Like where you already typed in the formulas and the cost,
Yeah.
you take that cell and drag it to the right.
Mm-hmm.
It'll-
But I don't have the annual net cash flows though.
You just type them in, right?
But not for the combinations, not for the bundles.
Well, you bundle the costs,
Yeah.
so when you pull it over, it references the cell next to it.
I don't think I follow, but that is okay. I'm glad you found a shortcut. I'm just going to add these up so that I've got the combination of the annual net cash flows.
I see the present worth formula too, what you're doing, for some reason,
Yep.
you get a crazy number.
So for the present worth, what we're doing is the rate is 12%, NPR is 8, the payment is whatever, oh, you got to put the negative value of the payment. Remember how it changes the sign. So you put the minus sign and the annual net cash flow is in the payment field, and then outside of that is where you add the cost. So then we can do that for all of them.
I don't know why. I don't know how that's supposed to percentage.
Okay, in our case, there's 10 bundles. And so, I mean, that's a lot, but it's not like a million or anything. It's easy for us to see which is the best. What should we do? Like, apply the decision criteria. Which bundle of project options should be selected?
Well, the greatest place.
Okay, so which one is that?
AC.
AC is the best because it has the most money. So the way to pick it is like, remember the max function equals max, and then you do a range. So here, if we do max, then it'll tell us what is the maximum amount. So we could label this as the maximum project bundle value. And then just to make it easy to find which one it is, we can do something called conditional formatting. So if you highlight these values, so highlight the present worths of the bundles, and then here on the home ribbon, if you see conditional formatting, let's try that. So we want to do top/bottom rules, and we want to do the more rules. So format only the top or bottom ranked value. Okay, that's what we want to do. We're going to choose the top one value, and then the format that we're going to have it do, if I click on the format here, then I'll have it do bold and maybe also I'll fill it in with like light green shading. Okay. So now what it's going to do is in this range that I selected, it's going to analyze it, and the top one, it's going to turn green and bold the text. So okay. And it picked it for us. And so that makes it easier to find like your best alternative in a situation like this. And if we wanted to apply the conditional formatting, it basically just takes the sting out of sorting through and staring at row after row of data. This was only 10, but I've had data sets that were hundreds of thousands of rows long, and what you're trying to find is like the biggest rainfall event in 30 years. You know, you've got 365 days and maybe lots and lots of years of data, and you're looking for what's the highest value. So this is just one of the ways that you can find it. Okay, 5:14, we're out of time. Let's revisit these announcements just to refresh our memory where we're headed. So the assignment, I've given you the homework, which is basically the same idea as what we just did in the in-class exercise for problem 1. And problem 2 is just to kind of whet your appetite, getting started, some of the ideas for the project. So that's due on Tuesday of next week. That's it for tonight. Let me know if you've got any questions. I'll see you on Tuesday.